So I'll start with number 2. Number 2 is actually somewhat difficult, but I want the reduced radical. So I want everything in a radicand of the same root. That's the thing. Everything is in the same root of a radical. And 2 is kind of tricky to do. We're going to distribute this exponent. We have a property that talks about a and b both to the x. We can distribute the exponent to some degree. So 2 times 3/4 is 6/4, and we'll reduce that in a second. 2 times 3 is 6 over 4. 8 times 3 is 24. Sitting over 4. 1 times 3 is 3. Yeah, 3. 3 times 4 is 12. Now, I've got a pair of like terms here. See those guys? And I have a property that says x to the a over x to the b is x to the a minus b. So I need to figure out what 6/4 minus 3/12 is. Well, 3/12 reduces down to 1/4. So it's 5/4. Awesome sauce, right? I think it's pretty cool. So that gives me an a to the 5/4 up top. And I'm going to leave this b as a 24/4. The reason I'm leaving them and not reducing it down to 6 is because I want everything in the same radical. Actually, it doesn't matter. Ignore that. I'm being silly. This guy is perfect. Like, this guy does not need a radical. No radical needed. This guy needs a radical, right? And furthermore, once I write the radical, maybe you'll see that you can actually do something with it. Maybe you won't. I don't know. We could think of it now as this is a to the first times a to the 1/4. You know, because 1 plus 1/4 is 5/4. I know that's really going to bother some kids because y'all in fractions, you don't mix. You're like water and oil. Anyways, this is the only guy that needs a radical. Needs that radicand. So we're going to have an a to the first, a b to the 6th, and a 4th root of a. And there you go. Like I said, it's kind of tricky. It really is. Let's look at number 4. 4 might look intimidating, but it's really not. It's actually pretty simple. We have a cubic root of 4, which you cannot evaluate. It's a friggin' decimal. Sitting over the cubic root of 27m cubed. Now, you guys know that the cubic root of 27 is 3. So I evaluate the bottom part, and I get a 3. And think about your x to the p over r rule. This guy right here is m to the 3rd over 3, power over root, which is just m. And we're left with a cubic root of 4 up top. There's your full simplification. You know, I'd love to do number 3 for you, but you really need to sit down and figure some things out. All right, simplify in such a manner that all exponents are positive. Well, number 7 is pretty simple. So let's just look at number 5. Let's focus on like terms here. Oops, that is not what I want. See that guy? Your x to the negative 2nd over x cubed. Use your property of x to the negative n is 1 over x to the n. And let's make this 1 over x cubed x squared, which is obviously x to the 5th because 3 plus 2 is 5. And here we have y cubed over y to the 8. Well, we subtract exponents and we divide, so that also ends up y to the 5th. Now, your numbers here are 4 and 16. That's 1 over 4. That's not too hard. I don't think it is. Now, I do a little multiplication here. 2 times negative 5 is negative 10. All right, think about x squared times x to the negative second. We add exponents. So that's x to the 0, which is 1. So 1s are understood. I'm not even talking about that one. Then we have y cubed times y to the 7th. That's y to the 3 plus 7, which is y to the 10th. And that does it. That's that one. I'll leave, probably should have done 8, but I'm going to leave it for you. Just make sure you distribute that exponent, even to the 2. 11 is like super easy. Focus on that exponent. All right, let's look at 10. This 3 has a negative exponent. It's actually 1/3. I think I'm just going to do a real quick rewrite. X squared y cubed times this negative 5 has an understood 1 exponent. So that's what it looks like. All right. We have 1 times negative 5, which is negative 5. Y cubed times y to the 7th is y to the 10th. Down low, 3 times the understood 1 is 3. X squared times x squared, x to the 4th. This guy has fractional exponents. And look at that guy right there. Negative exponent. Again, think about your properties. 1 over x to the negative n is x to the n. So we're going to shift that 4 up top. It's going to make it 4 to the positive first. There's already a 4. And let's focus on these guys. You've got x to the 2/3 over x cubed. This is subtraction. This is 1 over x to the 3 minus 2/3. We're not going to use mixed numbers, so think about 3 being 9/3 minus 2/3, and we get 7/3. All right. So down low, there's an x to the 7/3. Y's are easy. We're going to shift that down low. Oh, that's to the 3/4. So I have to figure out what 8 plus 3/4 is. 8 is 32 over 4. 32 over 4 plus 3 over 4 is 35 over 4. All right, last step. Figure out what 4 times 4 is, and I believe it's 16. Easy peasy, lemon squeezy. I say that, but the reality is I know how kids treat exponents. I kind of want to do 12, but like you need to do 12 because like it's really easy. It's actually very easy. You just plug in numbers, kids. You know, and you're going to simplify to some degree. That's all you do. Simplified radical. All right, what is the reduced radical form of each expression? Let's just look at this one. Now, these are both square roots. All right, let's multiply like terms. We're going to have a 2. This was a 2. X to the 5th times x to the 7th is x to the 12th. Y to the 5th times y to the 6th is y to the 11th. Now, we have an understood 2 on a square root. Okay, so we're going to think about x to the p over r. Think about that rule again, x to the power over root. Well, this is not a 12. Looks like a bad 12. So there's an x to the 12 over 2, which is x to the 6th. So I'm going to have an x to the 6th outside. All right? I'll leave a little space. I cannot take the square root of 2. Now I'm focusing on y. Y to the 11 over 2. Well, what that is that is y to the 5th times y to the 1/2. I hope you agree with that. 2 enters 11 5 times with 1 piece left over. And so I can pull the y to the 5th part out, but I'm left with a singular y inside. I know it says 1/2, but remember, power over root. And it's simplified. And there's that guy. 15's a bit of a rough one, I think. But I think you'll figure it out. And there's apparently 2 15's. All right, the interest rate required to increase your investment P to the amount M in months is found by rate equals amount that you have after time divided by P, the principal, raised to the 1 over M minus 1. What interest rate would be required to increase your investment of $3,600 to $6,400 over 7 months? That's a heck of an investment. Round your answer to the nearest 1/10 of a percent. So let's see here. 3,600 is my P, 6,400 is my A. So rate is 6,400 over 3,600 to the 1 over M. M is 7, and then take away 1. Like, this isn't a hard problem. If I wanted to, I could attempt to do it by hand. Actually, by 4. But it wouldn't be a pretty answer. Like, I know this reduces down to 64 over 36, which is 16 over 9. And I'm supposed to take the 7th root? Yeah, I can't do that in my head. It's not mental. At least not easily done. I mean, you can, there's techniques for evaluating this that you learn in a calculus class, maybe. Depends on the calculus teacher. So just push buttons on that. I don't know why anybody would do it, but you know, one day we may not have technology anymore. Who knows? So we got 6,400 sitting pretty over 3,600. We're going to rooftop that to the 1/7. And then we're going to take away 1. And that's your interest rate. Now remember, that's per month. That's 8 point, well, I'll write down 4 decimal places. It's 0.0857 per month. But this is a decimal. And we move the decimal 2 positions. So it's about 8.57% per month, which is really good. That's per month. Your investment increases by nearly 9% each month. It's amazing. And I'm sitting here kicking myself in the butt because I didn't put money in Bitcoin back in 2011. A 10 million% increase since 2011. What would I do with that kind of money? There'd be signs, I can tell you that much. Anyways, there you go. There's your homework. Enjoy.